Alright, this is problem 4-1 from Hibbeler's Fluid Mechanics. And this problem states, water flows along a triangular trough with an average velocity of 5 meters per second. Determine the volumetric discharge and the mass flow if the vertical depth of the water is 0.3 meters. So this is the diagram, this is what we are given, and we're asked to find these two things. So firstly, volumetric discharge Q can be expressed as volume times area, or velocity times area, or volume over time. We'll be using the first one here, and our trough can be seen as this kind of triangular object. Split this in half. We have two right triangles. So with one of these right triangles, here, I've just transposed what we were given. There. So with this, now we know, let's see, that we're looking for H. Goodness me, why did it do that? H. To find H, simply we have to do 1/2 our base times, it's not going to be our height, it's going to be our height times 2. And why would it be height times 2? Because we aren't finding the area of just one of these triangles, we're finding the area of the entire trough. So when you plug this in, it's going to be 1/2 0.3 times 0.3 tan 30 times 2, which is going to be equal to, and this is going to be our area, .05196. So now that we have that, Q is going to be our velocity, 5 meters per second, times our area of 0.0519 meters squared, or 0.2. Oh, my apologies. A little too much. I forgot about this angle here. This is 60 degrees. Oh, sorry. This angle here. If you look at the trough sideways, it's going to look like this, with this here being the ground. This angle being 30 means that the flow is going to actually be the velocity, or in this case, our 5 meters per second times the cosine, because I guess we were trying to find the, if you look at this, it's going to be velocity here we are taking the area here. So when you put this together, it's going to be 5 meters per second, cosine of our angle. Or this might be acceleration, times our area here, which is going to be 0.0519. Okay, so we take this, now we multiply it by 5 cosine 30. Now we get our 0.225. I think this is the only problem we need to do this with, and I'm assuming it's because of what I've stated here, but this is a bit of a lapse in my understanding. Assuming that they just took the velocity funny. Like, if someone can better explain why we have to do cosine 30, that would be helpful. I know I'm the one teaching, but I just know this is how you solve the problem. Alright, and then lastly, it's going to be m dot, which can be expressed with rho times v times a, and we are told it's water, so this is immediately 1,000. The velocity is given again, I think it's going to be just 5, or no. This here is our Q. V dot A, see this? So we could just plug this in as 5 and then our area here, or we can just do rho Q. So essentially we just take our number and multiply it by 1,000. So it's going to be our mass flow is going to equal 225, and the units are going to be kilogram per second, and this is going to be meters cubed per second, and that is the correct answers.